Hi guys, KeyShard is a distributed key generation platform built on top of Fluence using the Frost scheme. Frost is a very famous threshold scaling scheme which uses a T out of N scheme. So what it really does, it means is if one secret is distributed among multiple peers using the Shamir secret scheme, and then it is reconstructed again for some threshold of participants. Now this is very useful in today's world, as we know that like for example a crypto private key can be distributed among multiple pairs, like making a DAO essentially is what I'm trying to say, that among multiple pairs you control the funds of one wallet and um, it can make some sort of a DAO. So yeah, so there are many applications of KeyShard. I will show you a demo. So this is some sort of simulations that there are 5 participants. I will open the console for this one because you will see the working and it is easy for me to keep the track. I have console logged all the outputs. I will go through the code. So I will start. Oh, I have to enter a secret, so it has to be some sort of number. Let's say 123443. Now this number, as we know, all calculation in cryptographic world, even in the Shamir protocol, takes over a prime field. So that for this it is, I think, FP256. So it's a 256th prime in the G to the power n minus 1 field. So I will start the key registration for every participant and eventually move on to all this. So the Frost is a 2 round scheme. So I will start the key generation for every participant. As you can see the bytes coming in. It was very difficult for me to figure out how this communication will take place between the Fluence nodes and in the Aqua. So I finally figured out that it has to be some sort of serialization. So I'll add the messages. I'll add the messages. I'll add the messages and I'll add the messages. So message adding is also one of this. So this is the whole flow of the Frost algorithm. So you start with the key generation. Every pair has its own key. Then each gives the secret, the message part of it, and it then gives to a not it does not give to someone, but it keeps it to ourselves and pools those messages collectively and it adds those messages. So we will see that in code. I'll start the round 2. I'll start and I'll add the shares and I'll end round 2 for each. You can see the threshold key come in. So this is the threshold key in an elliptic curve. So in an elliptic curve, the threshold key must be same for verification of the Frost protocol. So yeah, you can see that the threshold key is same. And I'll end round 2. And now I can reconstruct the secret. As you can see, my initial secret in the Mersenne prime, I can reconstruct it again. And 1, 2, I'll add 3 arrays. You can see my 3 messages and I'll reconstruct the secret. And as you can see, the secret comes out to be the same as the initial value in the Mersenne prime field. So yeah, so this is just a demo of how we can use the Frost protocol. Now I will dive into the code. So what I'm basically is calling through a gateway. This is some sort of an architecture, a gateway which tops on the Fluence network. This is done from the Fluence init CLI command. You give a given gateway, which is a serverless Fastify server. So it basically has exposed all these endpoints. So I will give you my api.md. You can check all this in the docs. So I'll show you the ones that you can see how the implementation happens detailedly through the code. The API references, the API reference is given all in the README, right? So yeah guys, that was my demo, I guess.